There we go. Well, good afternoon, everyone. My name is Mark Garneau, and I'm joined today with Janice Nowakowski. And I'll get this thing out of my way. There we go. Okay, and this is, part 2 or part 3 of our series. The first session was more introductory, so it's formally the second part in looking at different kinds of instructional routines. And today we're focusing on sharing math thinking and modeling notations. I'd like to begin, of course, by acknowledging that where I work in Surrey schools, and I work and learn on the unceded shared territories of the Coast Salish. And I acknowledge the Katzie, Semiahmoo, and Kwantlen First Nations who have been the stewards of this land since time immemorial. And we, of course, would also like to acknowledge the communities and territories from wherever you are, wherever you work and live. And we want to be mindful of that and appreciative. So very quickly through our agenda here, we're going to do an opening task. Quickly cover again, connecting back to the series in terms of why of instructional routines. We'll have a few minutes to give opportunities for people to share, and then we'll zero in and focus in on the routines that highlight the sharing of math thinking. So our opening task, we're going to do a fraction talk, and you have a choice. So choose the first image or the second, and I'd like you to communicate as best as you can in the chat one of the fractions that you see and explain how you see it. But don't put anything in the chat yet. You're welcome to start typing. We're going to wait a minute before people start actually entering. So choose a fraction that you see in either diagram, represent the fraction, and just a quick explanation of how you see it. I'll let you share in about a minute. Hi, Jen. I know you wanted me to say something to make sure your audio is working. So here I am. Sounds like you heard it. Okay, everyone, feel free to start putting your thoughts into the chat. You're also welcome to unmute yourself instead if you want to say something. Okay, so there's a lot of different, I can't even keep up with all of the different thoughts. And so normally in a fraction talk, we would take these one at a time and try to record the thinking, and visually especially. So there's the marking up of the diagram. There is the mathematical notation that we would include as well. And so I'm just going to pick up on one of these and say, where did I see that one? Oh, I can't see it now. There's something about, oh, there it is. So Katie talked about the small pink triangle on the bottom right. This is in the first image, is 1/18, because I can fit 18 of those pieces into the total square. So in that situation, what we're looking at is this pink piece. And that color isn't going to be very helpful because it's right up next to the blue. So I'm going to pick, what's a good color here? Well, you know what? I'm going to pick white actually. So she was looking at this pink triangle and saying she can fit 18 of those. And that is certainly not something that is easy to see, but I would invite Katie to explain how she sees 18. And I think I know what she's thinking because, and Jacob also picked up on this, that we can kind of see that one way of looking at this is to notice that, oh, that yellow square that we could actually split up this whole thing into 9 parts. And the pink is one of those parts. So we can actually fit 18. The important idea here with what Katie has shared is that it's a similar kind of thinking that many of you shared, no matter which fraction you were looking at. And that is looking at the whole and identifying a part and understanding or expressing that fraction in terms of saying, of the whole, what fraction can we say is being represented? Now, these are two very, similar but different examples. They've been divided up into different numbers of parts. Even the shapes are a little bit different. The one on the left is obviously wouldn't be one that I start with, but the one on the right might be, where I'm using a fraction image involved with Cuisenaire rods. And we could, Janice will unfold a little bit later about, how we execute these kinds of things in terms of, maybe having several copies of the image so we can represent a number of them at the same time, and make connections between them. How are these strategies similar? How are they different? We could also extend this kind of task as well with some interesting questions besides just what fractions do you see, but how is one fraction related to another fraction? So in this case here, if we know that pink is 1/18th, well, what does that say about the green trapezoid there? And can we use one to inform the other and how those are related? Are there any two fractions that come together to make a new fraction that maybe we're targeting? Or let's say we wanted to target a specific fraction. Is there any way we can identify 2/3 in this fraction, and what pieces would we have to put together for that? We can give value. What if that whole shape has a value of 9? Then what's the value of each part? Or vice versa. Let's say the little pink triangle has a value of a certain number, then what would be the value of the other pieces? And that kind of brings in a lot of the proportional thinking. So we can start to see how even from those early ideas of fraction and parts and wholes can grow over time once kids make more sense of fractions into relationships and multiplicative relationships, that proportional thinking between parts and integrating number as well. So I'm just going to clear my annotations and stop annotating, hopefully. There we go. So I'm going to pass it over to Janice, who's going to talk about some fraction talk images some more.
Great. So these images are from the BC Numeracy Network, and they were shared on Twitter last year. We did a focus on instructional routines, and each month we shared a new instructional routine image. These are part of our card set for instructional routines, and if you're interested in ordering those cards, I think they were mentioned in the first session of this series. We can pop Sue Robinson's email in the chat, and you can contact her for more information. These ones are unlike the ones that Mark just shared. They have one color to focus on. And so this is a little bit more sort of structured in terms of thinking about what fraction do you see, and having this one color focus you in terms of area is a connection, as well as decomposing shapes and quantity. And I teach in the Richmond School District, and one of the language frames that we use a lot when doing number talk images and fraction talk images is if and then. And Mark actually used that when he was explaining the earlier fraction talk images. But if we know this, then this. And by providing that structure, it gives this structure of not just language, but also of explanation and justification building into your fraction talk. So again, if you'd like to choose one of those images and share your thoughts about it in the chat box, that's great. We're going to do some things that are going to, be more interactive, and others are just going to be sharing information with you. But the language that we drew upon for the instructional cards was, what fraction or fractions do you see? And then how do you see it? So that explanation, what unit fraction you focused on, or what shape, what measurement, what quantity, and then how did you use that information to figure out other fractions and related fractions. Forward, Mark. And this is an example from a grade 4-5 class, and I used an image from fractiontalks.com, and we'll share that link again with you. And those images are all curated by Nat Banting in Saskatoon. And we had done fraction talks before in the class where I had done the notation. So students expressed verbally their thinking and their reasoning, and then I would record around the image on the board. This was later in the school year, and this is how sort of math talks and fraction talks, number talks evolve, is that once the students have seen that notation being modeled, then they move to doing the notation themselves. And so the students used a variety of different materials, plastic sleeves, pieces of paper, their notebooks, Post-it notes, to help them record their thinking. And so many of them were able to express and visualize why the blue triangle in that image was the fraction it was. But then they had to justify and explain their reasoning. And they used, again, you can see in the images, different ways of approaching that. And again, some students were like, oh, I've got it, I figured it out. And you can see that the student on the bottom right corner there, the nudge for her was, can you think of it another way? Can you visualize this another way? Can you use a different unit fraction? So changing the fraction that you're playing with to help you think about other fractions. So this is the website we mentioned, fractiontalks.com, and Nat Banting is out of Saskatoon. And these are the 6 different categories of fraction talk images that he has available on the website. And those are sent in from math educators all across Canada. And so squares, triangles, manipulatives, there's tangrams, some Cuisenaire rods, and then photographs that people have taken as well, sort of math in the wild, math when people notice things outdoors and take images and think that would be a really great fraction talk. And then some that are constructed specifically for particular mathematics and, being very intentional. And again, you can just drag those to your desktop and project them or copy them for use with students. Oh, this is the bulleted slide, I think, right? So why fraction talks? The language of fractions, I think, is really important. Fractions are first introduced in our curriculum formally in grade 3, but students younger than that have lots of experience with sharing and dividing things into parts. But the fraction talks also help elucidate that connection between pictorial and symbolic representations. And then all sorts of curricular competencies promoted in fraction talks: reasoning, justifying, vocabulary development, conceptual understanding, estimating and visualizing, and communicating student thinking. And then, as Mark also mentioned, that connection to multiplicative thinking and proportional reasoning is really developed as students get older and have some experience with fractions and can play with that idea of what the unit fraction is and the relationships between different visuals. And then again, connecting to other different representations of number or area as a representation. So making those connections between decimal and percentages, ratios, in order to deepen students' conceptual understanding of fractions. And the fractiontalks.com and the other website, bcnumeracynetwork.ca, has a whole page dedicated to instructional routines and more resources and links there as well.
Yeah, okay. So we wanted to come back and what Janice just explained, even just with fraction talks, how you really see the instructional purpose behind them. There's really key essential understandings in mathematics, as well as the curricular competencies that emerge. the community that can be built within a classroom when we are collaborating, sharing, thinking, and learning from each other, the engagement, the mathematical interest of whatever the talk is around, and just the fact that students are owning their thinking is a means to engaging. The practicality of it, because these don't have to take very long, and there's just so many things available, and observational assessment as well. We can learn so much about what our kids can know and do by engaging in these tasks. So last time we looked at the similarities and differences kind of routines, whether that be the same but different routine, which one doesn't belong. We also looked at something called math match. And we were hoping that you would try something. And maybe you've already tried something even before that session, but hopefully you've tried something since that session. And we just wanted you to have the opportunity to share any successes or challenges that you faced. And even if you haven't tried something, maybe you've at least thought about what you might be wanting to try, and you can talk about that. So I'm going to pause the recording and hopefully be able to get into breakout groups here. It's probably easiest if I stop sharing my screen for the moment. There we go. So pause. Okay, well, I hope that was worthwhile. I was only able to drop in on a couple of the groups, but it looks like there was lots to talk about, and that's great. Hopefully you found that was helpful to hear what others are doing and to have the opportunity to share yourself what you're doing. I'm going to go back to sharing the screen, and we'll pick up where we left off here. Here we go. So off of sharing, and Janice is going to pick it up with number talks.
Great. So number talks is probably like the original instructional routine. It was developed decades ago. Mark, there's some bullets. Maybe if, I think they're transitions, so maybe you just, yeah, you can just put them all up for right now. Developed decades ago by Ruth Parker, Kathy Humphries, and Kathy Richardson. So those are sort of the three key authors to look at. Current authors also include Sherry Parrish and Kathy Fosno. The original number talk sort of philosophy, this was an oral or verbal routine that focused on mental math strategies, computational fluency, with the teacher as the facilitator, recording students' thinking. And so this is where how do we capture students' different strategies, and how do we model mathematical notation of ideas. So you can see on the right, there's a photograph from a number talk that I did with probably a grade 1 and 2 class. And, using the visual tool of the 10 frame to provide an access point or a starting point for some of the students, writing the equation up, 8 plus 7, and then having them share, how did you figure that out? And giving them some wait time or think time before they do that. A lot of teachers use some sort of number signs or hand signals and build that into their routine of doing number talks. I ask children to not put their hands up, and we talk about the psychology of that. And I explain to them that many researchers have looked at this in a classroom, particularly in mathematics, and how if a student beside you puts their hand up, you're less likely to respond. Your brain is getting a message that, oh, someone else has figured it out already, kind of thing. So you want to build this culture with number talks that we're all going to contribute. We all need to think about this and figure it out. And so I give them some time. Sometimes I'll do a turn and talk before we share to the whole group, so students have a chance to verbalize their strategies and do that oral rehearsal with someone else before they share to the whole group. And then I ask students to share their strategies. And I record using, the notation that you can see up here. Sometimes they say, well, I decomposed, and they might say break apart. And then I'll say, oh, so the math word you could use is decomposed. And, I model that language as I'm recording as well. And then I think a really sort of significant part of this, and to really attune students to listening to each other, is I'll say, who has a different strategy or a different approach? So they need to share something that's different than has been previously shared, especially with younger children. They often have their hand up and just want to share what's in their head, and they're not necessarily paying attention to what others have said. Sometimes after we've done number talks for a while, I'll also ask them to connect to what the person before them has just said. So my strategy is similar, again, going back to our last session, similarities and differences. My strategy is similar to so-and-so's, but it's different because, and again, that's getting them to really pay attention to what each other is thinking. Next one. And again, just more, this is grade 2, 3, 1, 2, 3, 4, sort of that range, really looking at whole number strategies for addition and subtraction that can be then used with other numbers as well. But you can see on the left a variety of notations. Number talks usually involve a string or a sequence. So you might start with 8 plus 7 and then move to 38 plus 7. And then in this case, 48 plus 37. So this idea of a string or a sequence where those questions are connected, and students are hopefully seeing those equations living in the upcoming equations as well. And they can think about how they can use the strategies they used for 8 plus 7 to think about 48 and 37. Decomposing by place value using an open number line, all very common strategies and different ways to notate. And you can see on the right there, the decomposing by place value at the bottom, and then the counting on or adding up using benchmark numbers on the open number line. And I would say that use of the open number line for many of our teachers has really opened up the way that number talks are done across the grades. So with fractions, with decimal numbers, etc. Okay, next one. One of the things that we have found over time, and again, I've been doing number talks with teachers in my district for about 8 years now in a really focused way, is that part of that developing mathematical discourse is being able to communicate really clearly and understand each other. So naming those strategies as well. Sometimes they're named after the student when we're first learning them because they're the ones that share it or come up with that. But then, I'll say, when we think mathematically, we call that decomposing or we call that compensating. And then, the students will name that when they're sharing their strategy. And then other students will make connections and go, oh, I understand what you mean by compensating, but I compensated with these numbers, and making that connection there as they're sharing. So we're going to do one together. It's a little bit more difficult to do on Zoom, but pretend we have a whiteboard and think about how you might respond to this question, 16 times 35. What is one way you might figure that out? And then once you've got one way, try and think of another way, and then try and think of another way. And then think about how you would record that. If you were the teacher and students were sharing the strategies that you've thought of, how would you record that? To really highlight the mathematical thinking and the mathematical structure of how they thought about that. And if you could share your ideas in the chat box, or if you would like to unmute your microphone, please feel free to do that. We'll give this a minute or so. Katie, that's the strategy I go to too. Are you comfortable unmuting your microphone and sharing how you might develop that idea with students?
Yeah, so what's really interesting, Janice, is that I only learned that like about 4 years ago, right? So it's so interesting to me that how that works, because you can break the numbers apart, right? When I teach it to students, or when I work with students, I start with doing you can multiply any number by 5 because you can multiply it by 10 and divide it by 2, and that sort of starts the ball rolling, because then they can do that really quickly in their head. Yeah. So it's so interesting to me that I never knew that as an adult, right? That people did that. So, and I tell kids later, like I wish I knew this stuff, because it's empowering to be able to do that kind of mental math in your head.
Yeah, absolutely.
So I'm interested to see how everyone else breaks it down with a student, because there often is a student that will come up with that just says, well, and they'll say this, well, I've done it like that forever. I just do. And I'm like, okay, that's awesome that you were, and then we share it. Because for someone like me, I didn't know that. Someone showed it to me. I'm like, that is awesome. Does it work all the time? And you start playing with it.
Right. And that's a, does it work all the time? That's such a good inquiry question, right?
Yeah.
And that being able to generalize that strategy across different types of numbers too.
And I think it's really cool when we say, and it works with decimals and fractions, like, get out. Like, well, those are just numbers, but.
Yeah. And I've encountered students who just have such strong number sense. They just know that it works. Like it's not a trick. They actually just know that, this makes sense. Other students I have found, starting at about grade 4 or grade 5, we developed this understanding of that strategy through visual arrays.
Yes.
So, building arrays, like if you can visualize like a 2x8 array, and then if we half that and move those down, we create a 4x4 array. So it's the same quantity, but it's, transforming the array into a different orientation, but that models the mathematics of what's happening here. You're not changing your total quantity. I noticed someone in the chat said 20 times 35, because you could do 10 times 35 and then double it and then take away 4 times 35. Anyone else want to unmute and share a strategy?
I find when I do this with older kids, like grade 8 and grade 9, their fear of math is so high that they will only do it with an algorithm. Like they will double check it. Like it can't be that easy. It cannot be that true. I must make it difficult, and then I will feel I've solved it. And you say, you can do it that way. Oh, I don't know, Miss McCormick, a little bit too.
Don't trust it, right?
Yeah, I don't really trust it. I don't feel good about it because that did not hurt my brain, and I didn't get confused, so it cannot be math.
Yeah.
I ask a quick question. With the number talks, is it all mental math, or are students allowed to get whiteboards and done it? Like, what's your call on that?
Yeah, the original research and philosophy that number talks are based on is oral and verbal, and really focusing on mental math computation. But you need to read your room and know your students and know what experiences they have. Many students are much more comfortable recording on paper, and it's also, or whiteboards. The little mini whiteboards are a great tool, and many of our classrooms have a basket or a container of those, and that can be a starting place, at times of the year. I would say, really depends on your context, but you don't want to get reliant on that written form. You want students to use that as a tool to move them towards the mental math computation.
Thank you.
Anyone else have any opinions or thoughts on that? Just jump in, please.
I would just say that makes sense, because I think that for some of my students right now, their confidence in math is quite low. So if they've got that pen in their hand and they can have a go at putting, their thinking down on a whiteboard, but I could definitely see how throughout the year, slowly I would see if they could take that away and see if they can do that in their head. But definitely with this group of students that I have now, that, I mean, even myself, when I saw that 16 times 35, I panicked a bit and just so that I could, and I didn't go there, but I can see how that's going to encourage students to have a go, and then support them to come away from that.
Yeah. And it's interesting that you say that too, because I've also, the opposite I think is also true, that, as the educator, as the facilitator of, a number talk, you're recording their thinking and you're modeling, that notation. And often in this third term is when then students will start to come up and do the notation for their classmates, because they've been watching it all year. In terms of, seeing how I've been modeling the notation, and then they have the confidence to come up and record it on the whiteboard for others. Or I might have them do, we'll do a couple number talks a week orally as a whole class, And then, at the end of the week, I might put up 2 or 3 questions for them to choose from, and then show how they might solve them in a couple different ways and record it in their, their math notebook, just as again, turning that notation over to them. Anything coming up in the chat? Just dead air. Yeah. Yeah, I've been in lots of situations where, again, that culture of discourse and risk taking, takes time to develop too. And students realize, like, well, let's just try something. And, someone to take the risk and throw an idea out there that they can all build upon as well.
Yeah, and it also, it transforms over time how kids view what does it mean to do mathematics and to be successful as mathematical thinkers.
Yeah.
And that the algorithm that they might want to just glom onto is probably the least mathematical way of approaching these.
Mm-hmm.
Yes, you can compute an answer, but these other things are really what it means to be mathematically thinking.
Yeah. And we say so much in the space that we give to time and our patience, and encouraging that risk taking. And I use the terms, we want you to be flexible and fluent. I don't know how many times I say that. Like, that's what mathematics is being flexible and fluent. So yes, you've got one way. Now let's think about another way and another way and another way. And then that's your role while we're doing this number talk, is to not just shut your brain down in terms of thinking about this question, is to keep percolating and thinking about it in different ways. Mark, I'm just looking at the time. I think we better move on. So again, there was just my notation for that particular one. And the language of our curriculum, that having a doubling strategy is right in there, and then annexing, the 0 and then multiplying by 10 again. So using a known fact like 8 times 7 and then multiplying by 10. So students explain that, and that might be how I record it.
So also in the interest of time, I'm going to go through these very quickly, but just to get across the idea, and somebody actually brought it up earlier, it's that, the sense of number that we're working with kids to develop and apply and develop these, become fluent with some strategies, that extends to other kinds of numbers. So when we start to see something like decimals, it's not this whole new thing, it's still subtraction. And so I could look at something like this, and I might think of the compensating strategy where I take 4 away, then I give back 1/10. Or I might use a counting up strategy, counting up to 4 with 1/10, and then up to 7 with 3 wholes, and then another 6/10, and putting those parts together. So there's a lot of rich strategies in thinking, and they're all exactly the same as would happen with whole numbers. But now we just have to extend our thinking, and we're not counting ones anymore. We're counting tenths. Something like percentage. There are a number of different ways we could approach this. And I know when I was growing up, there was one way, 0.35 times 60. And yet in a number talk situation, and really trying to think, well, gee, if, I know what 10% is, and if I know what 10% is, I can figure out 5%, and I could put those together to make 35, or I could get the 25% and then add 10 more percent there, or take 50% and remove 50. I mean, there's a lot of different ways of approaching this. So percent is another really rich area to have a number talk in. And moving into the secondary schools with fractions. And Janice brought up earlier with those number talks, there's the strategies that, the thinking that goes into it. And then there's also the representations. So, a student may take a common denominator strategy with this, but there's a number of different ways to represent that. There's a symbolic representation. There's concrete. Let's say they were using pattern blocks and switching everything to little green triangles or Cuisenaire rods. Perhaps they're using a number line and dividing the number line into thirds and sixths. But then there's also the strategies. Common denominator is just one strategy here. Maybe it's decomposing one of the fractions. Yeah, whole numbers are not the only things we can decompose. If I look at the 2/3 and I know I need one more third to make a whole, then I can decompose the 5/6 to taking that third out and giving it to the 2/3 to make a whole. So again, all of these sort of rich ideas about how numbers are related, how even within one number, there are different parts that can be conveniently, that can be conveniently decomposed into to be able to combine with other numbers. It doesn't just happen in those early years. This is something we can keep carrying forward as we look into, even later numbers like exponents and radicals and logarithms and all of that.
All right, so here's just sort of the bullet points in terms of why number talks and why they're important. And I think we've hit on all of those things already, so I think we can go ahead. These are just some of the key resources that I recommend around number talks. You see the big one, green one in the middle. If you just had to get one, that would be the one I would recommend. Making Number Talks Matter by Kathy Humphries and Ruth Parker. Their second book is relatively recent, Digging Deeper, Making Number Talks Matter Even More. And again, this crosses elementary, middle school, and into early secondary in terms of the types of number talks and strategies that are explained in those books. They also focus on pedagogy and assessment in terms of that culture of learning and engaging in assessment. The two books on the left, the blue one is sort of K to 5, K to 6, in terms of number talks with whole numbers, but there are some decimal numbers, number talks as well. They also, for early primary and pre-K, they have some visual number talks with dot images and 10 frames, etc. And there's QR codes throughout that, so you can watch little video clips. Same for the green book called Number Talks, which focuses on fractions, decimals, and percentages and operations with those. And then on the far right, oops, sorry, back one, the far right, excuse me, is a relatively new book by Kathy Richardson and is available by Didax. There's number talks in the primary classroom. There's also, for those of you that are interested, there's one for preschool classrooms as well. Sorry, and there was a message from Jacob. Do you want the number strings that Sherry does? Sherry Parrish, I'm guessing that's what you're talking about. So number talks or number strings are a very big part of number talks. And that those go back to the original number talks. Kathy Fosno as well focuses on number strings or number sequences. And again, those examples that I built in earlier, starting with one equation and then amping it up and then amping it up so that first equation lives in the next series of equations as well. So they're strung together. All right. Next area, very much connected, another kind of instructional routine is called Number Talk Images. And Chris Hunter, who's with us today, he submitted several of these dot images to the Number Talk Images website. And so just again, we'll take a few seconds and think about how many and how do you know? So how could you explain your thinking? Or how do you see them? What ways, different ways might you decompose or group those dots or count those dots? Again, thinking about the age of the students that you work with, and then how might you record or notate students sharing of their thinking? So you can pop that into the chat box. Sorry, I'm not sick. I've got spring allergies and I've got a little cough. Ooh, 7-3 is good subitizing there. And often with these two, students will say, well, I moved this here and I saw this here. And again, as an educator, think about how you would record. We'll have a look at some of that, how you would notate the different ways that they thought about it.
I think we best
Yes, go ahead.
Forward.
Yeah. So another one, for younger children, I often use this as a first number talk image. There's a small enough quantity that if students need to count, they can count, but it also allows for some grouping and some, beginning multiplication as well. Go ahead, Mark. And I've been doing all virtual teaching this year with K through 7 students in our district who are learning from home. And so these are just some examples from small group instruction that I've done. So at the top left, this was with a grade 2-3 class, a group of grade 2-3 students. And I used the duck image and I did the annotation. So they unmuted their microphone and shared how they saw the strategy. And then I, like Mark was doing earlier, I used the annotation tool and circled the different groups and then recorded their equation. So I did that mathematical, the modeling of that notation for them to say, so, you know, I've added these parentheses, or what, you know, you're talking about groups, so that's multiplying, and add that symbol. Grade 2s and 3s are just learning about that. And then on the bottom right, I was with a grade 4-5 group of students, and I put up a Jamboard with a dot image. This is one of Chris's as well. And then they anonymously posted either by text box or by sticky note how they saw it. And then we discussed that as a group. So can you match, can you visualize what that person was thinking or what they were doing based on the equation or the notation that they included on their sticky or in the equation? And then this is an example. That's one of the images on the Number Talk site. And if you have a smart board, you can just clone that image multiple times, or I just copy and paste it several times on a slide to project. And one of the reasons I really like to do this, this is an example from the Number Talk image site, is it allows us to compare strategies. So I can record several different student strategies in the way they saw it. And then I'm like, okay, let's choose this one and this one. How are they the same? How are they different? Just to get that different level of mathematical thinking happening.
Okay, just as Janice talked about how there's that growth from the looking for additive relationships with the numbers and doing a number talk image to multiplicative and looking for groups or arrays. We can even extend that up into the secondary. If you take a look at the Sierpinski triangle, for example, and it's 423, so I'll jump right to it. We see these groups of 3, but we don't just see groups of 3. We see groups of 3 of 3, and then of 3. And so this is a nice visual thing where you can actually draw out the understanding there of using an exponential representation. And then just like with a number string, we could start with something like this and then grow to a next level of the Sierpinski triangle, or even further than that. And this would be an impossible one, not impossible, it would take way too long to count by ones. So what's an efficient strategy for getting a number? And it just leads to, you know, using powers of 3 to do something like that.
Me. So another type of Number Talk images extends the idea to focus on the unit. So this image here is in Christopher Danielson's book, which is called How Many? So how many what is the response, hopefully, that students might come up with. So how many avocados? How many half avocados? How many pits? So there's different ways that students can count and think about these images. And again, lots of them available on Twitter. Use hashtag unit chat and lots will come up. But one place or one person that's collected a bunch of them, we'll go to the next one, Mark, is Dan Finkel on his website, mathforlove.com. He's got a lot of dice images in particular. So he's got these collections of dice. And again, how many? How many dice? How many white dice? How many black dice? How many pips altogether? How many black pips? How many white pips? How many more white pips than black pips? I mean, so many different questions from one image. So again, his website has a whole collection of dice images, but lots of other unit chat images as well. And again, there's the website, which is curated by Pierre Montagna in Ottawa. I might have said that wrong, but Pierre, we'll just stick with Pierre. And he, again, collects images that are submitted through Twitter and email from educators across the world, but again, focus on so many of our curricular competencies.
So just a very quick run through of some other ideas. It doesn't just have to be about number directly, but other things that can be visualized mathematically. Here's an example of a percent talk what I find interesting about this is that the grid isn't divided up into 10 by 10. So how can kids, think about what would this be as a percentage, and how do they know, and what do they see? Um, Ratio talks. This is also from Chris Hunter, and there are many ways of looking at this in terms of, we have reds and blacks, but there are groups there that we can look in. What kind of equivalent ratios can we draw out of this? The part to part ratios, the part to whole ratios, and so on. Expression talks, where you might model something algebraically, and if these were algebra tiles, what different expressions how can we describe this using different expressions, and how are those expressions equivalent and connected? Graphs without numbers is something I like to do as well, where it's not necessarily about finding specific equations and getting lucky, what is the equation now, but what do we notice? What do we know about these graphs based upon what we see? What are some things that we can say to describe it? And again, there's some opportunities for different ideas, different attributes to look at, and so it can be a very rich conversation to have. Even data talks. I just pulled this graph today from our BC COVID data, and there's a lot of interesting things that we could draw out there, both in terms of the similarities between these different health regions and differences, and overall, how do things looking? What story does this data say? And so you can take almost any graph of data and have a lot of rich talk, again, through that same format of that open sharing thinking. It's meant as an oral exercise, which is because we could also do this kind of analysis in a much more structured, collaborative group way, and so on. I wanted to quickly show, and we're at the almost time here. There is a site, Michelle Reinhardt, who is Canadian, but now she moved to Texas because she got married, and now she's studying, doing her doctoral work at Harvard. HowWeTeach.com. She's got a section there on math talks, and her intention there was really, how can we bring this kind of routine even up into the secondary grades? And there's just a lot of great examples there of things that you can do and engaging in the same way. So here's a fraction of example, and there's some interesting strategies that can emerge through there. Writing equivalent equivalent expressions to an algebraic expression. This is a solving a systems thing, but because it's very visual, you could actually do this mentally. You don't have to write equations and solve and so on. Looking like a routine that's very popular at primary is today's number. Well, just because we're doing pre-calculus 11 doesn't mean we can't do today's number. We could look at a particular radical expression and think about all the different ways to represent it, meaning what other radicals are equivalent to it. What is an estimation for that value? There's a lot that we can say about numbers even like that. So we are at 4:30. So just a quick look at our next steps. And by the way, we'll be posting a PDF. We're sharing a PDF of these slides. So you'll have access to any of those things that we've shared. You don't have to worry about, oh, I didn't get a picture of that. So our hope between now and the next session is that you will try something and perhaps focus specifically around these routines that share their thinking, and for you to practice, because there's a real teacher component here. How do you facilitate that conversation? How do you record their thinking and notating of their thinking? What kind of connections between those representations and ideas and strategies can you make? Our big reflection that we want you to really focus on is, what do you notice about your learners? What are you seeing emerging with them in terms of what they're capable of through doing these kinds of instructional routines? So our next session is May 19th. It is on a family of routines that could be summarized under justifying a choice. And that will be facilitated by Susan Robinson and Chris Hunter. And we'll also have that sharing piece thrown in there as well. I see a thing in the comments about where these are going to get shared. We're still working on that. We do have the previous recordings. I think maybe there was a link mailed to the participants. I'm not sure, but we are looking at housing all of the links in one place. And as soon as we have more information to share about that, we will pass that along. The BCMT e-news that gets sent out regularly will have some information there. So that's all I have. I will thank you all for not just being here, but also engaging, sharing your thoughts, giving some feedback, and it's all really great to be able, even though we're not together in the same room, to still be able to learn from each other, engage and connect. So Janice, I'm not sure if you have anything more to say.
No, thanks everyone.
All right, I'm going to stop the recording. Stop the share.